Welcome, everybody. So let's see, we've got a fair amount of things to cover, so I'll try to go through this, but it's all recorded in case we run out of time too. It's kind of a long tutorial. So hopefully you remember what we were doing 2 weeks ago, where we were drawing all the intersections in the city, and we gradually figured out to get the coordinate system right and the projection right. Okay, I'm not going to demo that, but you were able to draw it. We were able to draw them correctly. And this is what the code looked like. Okay, so your most important routine for milestone 2 is your redraw routine. You have to have a redraw callback. Here I'm drawing all the code is in my redraw callback. You should not actually do that. Use helper functions. These redraw callbacks can get really long, so start making helper functions right away. But I just want to fit more on the screen. Whoops. Okay, and I'm going to plug my laptop in. It's lose battery. So I'll let you look at that and remember what that code looks like. It's just going through all of the intersections and mapping them to, let's see, I have my power supply here. Go. So it's going through all the intersections, projecting them into an XY position in meters on the surface of the Earth, and drawing them. And it draws a rectangle that's 100 meters by 100 meters, which works well because we created a coordinate system where that makes sense. Okay, so we do that, and Toronto looked good. This routine is speed critical. So in written document 1, you're talking about how do you make a program responsive and usable. So responsive is all about, you're fast enough, you're not annoying your user. Every time somebody drags the view, or they zoom in or they zoom out, you're getting redraws. Sometimes quite a few. If you use the mouse scroll wheel and you're zooming in, or you click on the map and drag it, you actually get a lot of redraws in sequence. So you want these to be fast. Okay, so how can we make it faster? Well, if you look at this, so remember this routine is being called over and over again. And we're in a loop. Anything that's not in a loop, we don't really care about. But we're in a loop that we go through number of intersections, so about 150,000 for Toronto, more for London and Tokyo. And inside that loop, we basically are calculating what is our X given the longitude, what is our Y given the latitude, and then we're filling a rectangle. Filling a rectangle is a fair amount of work, drawing pixels, but I don't know how to get rid of that right now. We'll talk a bit in lecture today about ways we can get rid of that. But for now, I'm just going to draw all the intersections. But I can do something about this part. That I can speed up. What do you think I can do to speed that up? So in particular, remember what we're doing in this course is you've created a load map, which gets called once when you load a map. Are the XY locations of these intersections going to change for a city as you draw it? Or are they going to be the same over and over again, every single time you redraw? So what do you think? That's a very leading question. So it might guide you towards which answer is correct. Any thoughts? Do these XYs change? No, these XYs don't change. Okay, it's just basically converting latitude and longitude of every intersection in the city into position in meters on the surface of the Earth. And that's not changing. The city's not moving. As you zoom in and zoom out, what's actually happening is the coordinate system is changing. So ECGL is changing how it maps your fill rect calls into pixels. But the actual calls you're making, these X's and Y's are not changing. Okay, so let's see, does that matter? Maybe it's so little work that who cares? But we could speed this up by moving it into load map, because every redraw we're doing this work, and it's constant. We could have just computed it once and saved it. So let's look at what's in those helper functions. So there were two. There's this X from longitude, and there's this Y from latitude. Let's just look at the X from longitude. It basically has 1 multiply, 2 multiplies, 3 multiplies, 4 multiplies, and a cosine call. Okay, so that's the work we're doing in it. We did this once, we wouldn't care at all, but we are doing it about 150,000 times for every redraw. So that might be significant. Okay, so what do you think is a bigger deal, the multiplies or the cosine? No? Okay, so nobody's jumping up and down. We're going to do a test. Okay, so I'm going to do a challenge. They challenge this table versus this table. Okay, so that table, okay, your table goes first. Here's your challenge. Ready? And speed challenge. See how fast you can answer this. Confirm. Okay. What is 2 times 2? Very good. Very fast. Okay, now your turn. What is the cosine of 2? Come on. Okay, judge, who won? Yes, okay, so was not a fair contest, right? Computing the cosine of 2 is considerably more work than multiplying 2 times 2. It's the same for a computer. Computer has an instruction to do multiply, can launch 1 multiply. For advanced processors, even more than 1 multiply every single clock cycle. Cosine, it will use a Taylor series expansion or a similar numeric technique. So it actually has a whole pile of instructions. Subroutine call does a whole bunch of math. Same as you, right? Somebody asks you to compute cosine without a calculator. It's going to take you a while. Okay, same for a computer. So this cosine is actually the biggest deal. I'd like to get rid of it. 1 cosine call, who cares? 150,000 per redraw kind of matters. Given that it actually turns out that it's just as easy for us to get rid of all of these multiplies too. So might as well, right? It may not matter as much, but we'll get rid of them too. So how are we going to get rid of them? We're going to move this to load map. And in your redraw functions, just remember that if you're often going to wind up with this cosine of average latitude over and over again, like not just for intersections, but for streets and so on and features, it's pretty easy to pre-compute that. If you pre-compute it, you can make your redraws faster, and it's not much code. So try to do it in load map. Okay, so what I'm going to do, okay, so we want this redraw to be pretty fast. 10 milliseconds would be really fast. 100 frames per second, it would be like silk. Probably won't get there. 100 milliseconds is going to be pretty good. 10 redraws a second. Not most teams won't get all the way there, but you're going to try to just kind of make it as fast as you can, because it will feel better. If it takes you 2 seconds, it's going to feel very laggy. If it takes a half a second, it'll feel noticeably better. Okay, so the way we're going to reduce this computation is we used to have a global variable that was storing the latitude and longitude of every intersection. We could easily just instead store the XY location of every intersection. So we'll do the projection once and we'll store it. We don't even actually need any more storage. We'll just change it. We won't store latitude and longitude anymore. We'll just store XY. So in load map, we're going to load this up. We have our vector of intersections, and we're going to basically pre-compute this XY location by calling our helper functions for every single intersection. And now our draw map, or our redraw function, sorry, looks simpler. So we just go through every intersection, and we basically, I've made this an EasyGL point2D. So this is just a class inside EasyGL, which is an XY point. It uses it for some of its drawing calls. So for maximum speed, I'm just going to store my intersection as a point2D so that I can pass it directly into EasyGL. So that's what I'm passing it. And basically I pass it 100 meters and 100 meters. So I'm basically saying, draw me a rectangle from the intersection at its lower left corner to 100 meters to the right and 100 meters up. And this will be a bit faster than what I had before. Does that make sense? Okay, so let me quickly demo that. And let's see, I've got lots of different functions in here. So let me just get rid of one of these. All right. Okay, so there's my drawing. Looks like it did last week, but the code looks a little different. Let me show you what the code looks like. It's basically what I just showed you on screen. Let's see. There are a whole bunch of these here. Okay, so this is a faster projection. Remember, we set up, the way we work with EasyGL, we do a bunch of setup code in our draw map. That's what this is. We tell it what our redraw function is, and then we call application.run, which passes control to EasyGL, and it'll call our redraw function whenever it needs to. And go to the redraw function, And here it is. It's just the code I showed you. Loops through all the intersections and draws them. And it draws them by looking up their XY location rather than computing the projection every time. I've also taken the code that I showed in the last lecture to do timing. So I've also wrapped some timing code around this redraw routine. Okay, so when I run it, it's going to tell me every redraw, it's going to tell me how long it took. And this can be useful if I'm trying to check if my redraw speed is good enough and also try to tune it by trying different optimizations and immediately measuring them. I'm in release build, right, which is good because I'm actually paying attention to time. Whoops. So let's say I do this. So let's see, as I zoom in, for example, move this down, you're going to see the redraw speed. Okay, let's see. All right, so should see the redraw speed. I think I need to run tab. Okay, so every time I click on this now, every time I get a redraw, you'll actually see how long it takes. So let's do a zoom fit. Okay, so that redraw took pretty fast, 0.006 seconds. So that's actually plenty fast. Let me zoom in a bit. Whoops, I think I hit the wrong button. Let's try that again. Okay, so let me zoom in, let me do a zoom fit. So it took 0.006 seconds. As I zoom in, it's actually getting a bit faster. It gets down to about 0.12 seconds. And it kind of stays there. As I move around, it's staying about there. If I go back out, it goes back to about 0.006. Why do you think it gets faster as I zoom in? So it did get about 5 times faster. Sorry, go ahead to a bit longer. Yeah, so it's less visible. Now, what's interesting is I'm not changing anything I do. My screen redraw draws all the intersections every time. I don't have any clever code in here at all. It's getting faster because this fill rect is actually relatively slow. Drawing pixels is relatively slow, fair amount of work. EasyGL first checks if something's completely off the screen. So as you zoom in, more stuff's off screen, the redraws do get faster. Okay? So you're going to notice that. So let me go back to, so I wanted to show you that too, just show you how you can measure speed. Okay, so let me go back here. Okay, so I also measured the code from 2 weeks ago. So with the whole map displayed, the new code where we pre-compute the XYs is about 1.5 times as fast. When we're zoomed in a lot, it's about more than 2 times as fast. The reason it gets a bigger speed up when you're zoomed in is we're just spending less time in the actual pixel drawing routines. So the overhead of those lat long conversions is relatively bigger. Now, all these redraws are fast enough. Like if this was your whole map and you basically had it at 0.02 seconds, it's fine, right? That's fantastic. It's going to feel incredibly smooth. There's no point in optimizing. But we're only drawing intersections right now. When you go and draw streets and features and so on, things are going to slow down. So this 1.5x speed up that we got can be useful, or even more when we're zoomed in. So does that make sense? So the takeaway from that is pre-compute what you can in load map. It's a low-hanging fruit in speeding up your program. Okay, next thing I want to talk about is how to react to mouse clicks, because so far we've just been drawing, but we haven't really been interacting with the user much except panning and zooming. So when we launch EasyGL, we set up things. So we set up a settings object, we set up the draw main, we do a few other function calls, and then we call this application.run, which passes control to EasyGL. And EasyGL will make calls to our callback functions when it needs our help. So it always needs a screen redrawing callback. That's not optional, and we already set that in a different function call. Application.run takes 4 more callbacks, and they're all optional. So far we've been passing null pointer for all of them, meaning I'm not going to give you a callback. Don't do anything when certain things happen. Now I'm going to pass it 1 callback. And the callback I'm passing it is the second one, which is what do you do when the user clicks the mouse inside like the main drawing area, the main canvas. That's where you're drawing your city map. So I'm by passing a name of a function, I'm saying when that happens, I want you to call this function. Now I need to write that function, okay? So it can be any name, but it has to match. Whatever function I said you should call, I better make sure I write that. Otherwise, it's not going to compile. I'm not allowed to, EasyGL is going to call a function that takes an application pointer. It's called a button event pointer. This is something that gives you some additional information about which button was clicked and whether shift is held down and so on. You can use that information or ignore it, but you got to basically have that in your parameter list. And it passes you in an X coordinate and a Y coordinate. Both of those are double precision numbers. They're both in world coordinates. So basically in the coordinate system you chose, where did the user click? Yeah, you'll be told the XY location. And this application pointer is just the EasyGL application. And that's useful because it lets you call all sorts of functions. If this wasn't passed into you, you might not be able to do things. All right, so you never call this function, okay? You will never call act on mouse click. EasyGL will call it. All right, so you just tell EasyGL that this function exists, it'll do the rest. Now you have to write the function. Okay, so we're trying to highlight an intersection. That's what we're about to do. So part of that is our act on mouse click function is going to need to find what the closest intersection is when a person clicks. So you're passed in this XY. How do you figure out what's the closest intersection? So what do you think? Any ideas? So it's not really hard. I'll tell you, sometimes students ask, well, could EasyGL just tell me, right? Could I just ask EasyGL what's the closest intersection? No, no graphics package can do that because it does not know what you're drawing. Okay, this is like a graphics area where you're drawing anything you want. It has no idea what you did. It just knows it's going to call some redraw function and you're going to do something. So you want to know what the person clicked on, you have to write that code. So what do you think? Yes, exactly. So I was going to repeat that in case anyone didn't hear it. In milestone 1, so remember your milestone 1 functions, right? We had you write milestone functions for a few reasons. One is as a learning exercise, but another one is a lot of them are quite useful in milestone 2 and beyond. So you have a function to find the closest intersection if you have a lat long point. Now, this isn't a lat long point. This is an XY in meters on the surface of the Earth. But if you wrote a conversion routine, and it's not hard to write that, just to do the conversion back to latitude and longitude. It's just the opposite of what you wrote in the X from longitude and so on. You can convert this to lat long and pass it to your milestone 1 function to find the closest intersection. So yeah, this can be done. Let's say I wrote a helper function or a couple of them, lat from Y, lon from X. I take those two values, I make a lat long point out of them, so I call its constructor. And then I just pass that position into my routine that I wrote in milestone 1, and I get the ID of the intersection back. Okay, so I need a couple of helper functions, and I call my milestone 1 function, and it's done. It's not the only way to do it. I mean, I can also loop through all those X, Y coordinates that I just stored and find which one's closest. That would also work, but this is probably easier because I'm just using a function I already have. Okay, and then I'm going to print out, the name of that intersection. So this will work for just printing the name of an intersection into the terminal. But in the milestone 2 handout, you're asked to do more than that. You're also supposed to highlight this intersection in the graphics. So people are supposed to be able to see what they clicked on. So any ideas on how I'm going to do that? You might not know, that's fine. It's conveniently on the next slide. But what do you think the high level approach is going to be to highlighting an intersection in the graphics when you click on it? Okay, so if you don't know, it's fine. It's on the next slide. Okay, so we're going to use what's called stateful graphics. And I'll explain that in a minute. I guess one thing you might be tempted to do is you might be tempted to say, okay, I'm going to color it in red. Okay, that's how I'm going to highlight it. So I want all my intersections in black except the ones that you clicked on, I want those in red. That's what I've chosen to do. So I could say EasyGL has these options for setting color. So I could say set color red. This isn't quite syntactically correct because I didn't put the namespace in it, but don't worry about that. And then I could basically say fill rect, with the right coordinates. Okay, so you might be tempted to do that. Just in this mouse callback, let's just draw a red rectangle at that intersection. What would happen if you did that? So it would draw, okay? But there's a problem with it. How long would it be on screen for? What would happen if a person zoomed in? So the person zooms in, what happens? Person drags the graphics, what happens? If they obscure the window and then bring it back, what happens? All of those things trigger a redraw. Okay, EasyGL calls your redraw function. With this approach, if I just have the mouse callback directly draw, my redraw function has no idea that you highlighted something. Okay? Which means your highlighting is going to disappear as soon as any redraw is triggered. And redraws are triggered all the time. You're moving a window around, you're zooming in, you're zooming out, whatever. So some students will do this, and it's on the rubric, basically. We're going to, the TAs will check for it, and they'll consider it not a very good solution. And then some students will argue, well, that's my user interface choice. You click on something, and then if basically you move the window, it disappears. It's not a logical user interface choice, right? Like nobody builds programs like that where if you move the window, some of what you just did disappears, okay? So you don't want to do it this way. Does that make sense? So it's like, it seems right, but we're gonna have to do something a little more elaborate than that because we want our graphics to be what's called stateful. In other words, they stay there as we redraw the window. Okay, so how do we do that? Basically, there's 3 steps. So the first thing is we have to register our callback function. So when the mouse is clicked, EasyGL does not know what to do. We have to tell it what to do. Call this function. So we did that. We already showed you how to do that. We have to write the callback function. So we have to find the intersection closest to the click. As I said, you might be tempted to draw it, but don't draw it there. It's not going to be persistent. So what we're going to do in our callback instead is we're going to record that it's highlighted so that future redraws can keep it highlighted. And then finally, we need to modify our screen redraw function to highlight it. Does that make sense? So 3-step procedure. Okay, so I already kind of showed this to you, but basically registering the callback is pretty easy. When we start the EasyGL window, we pass in the name of the callback function to respond to mouse clicks. Okay? And in general, this application.run takes 4 callbacks, just so you know what they are. This one is called when the window is first built, in case you want to do something right then. It'll only get called once, but it's your ability to say, I want to do something right when you create the window. This gets called every time the mouse is clicked in the graphics area. This is called every time the mouse moves in the graphics area. So that can be useful if you want to, like, somebody hovers over something, and you want to just have kind of tool tips, you can do that. And this one is called whenever the person types a key on the keyboard and they're in the graphics area. And you don't have to use them. So if we set null pointer, then it just won't be used. Okay, then we have to find the closest intersection. And we just wrote that. Okay, so we just did that on the previous slide. So got that already. But we now need to remember what intersection has been highlighted. And could we do this with a local variable? Okay, could I just make a local variable inside here? And that would be how I record that something's been highlighted. What do you think? So I see people shaking their heads. Yeah, I can't do that because I'm trying to communicate with the redraw routine. The redraw routine cannot see the local variables of this function. They're gone once I leave this function. So I can't communicate that way. So what I need to do instead is I need to make some global data. So I already had this structure, and I had a global variable called intersections, where there's one of these structures for every single intersection. So I'm going to add one more piece of information to it, a Boolean variable called highlight. And that's going to tell me for any intersection, so I'm going to have a whole vector of these, are you highlighted or not? In my mouse, in this act on mouse click, once I've found the right ID, which I did with that previous code, I just say, set the highlight value of that intersection to true. So I marked it as highlighted, and that's all I need to do, okay? Does that all make sense? Okay, I've made a comment here of initialize this to false. I should make sure these highlights are all false initially because I want everything to draw unhighlighted until a person clicks on them. Now in C++, you can actually say equals false like that. And that effectively wants an initializer. It's like a constructor. Okay, so when this global variable is created, all, this highlight will be false. And that'll be true for every single intersection when I make the vector of them. I don't actually want to do that. Okay, I just put this comment in initialize false. It's not wrong to do this, but it's not enough. The reason it's not enough is if you load another map, your program's running for a while, load one map, then you load a second map. This equals false, this initializer is only run once when the global variable is created. That's the very start of your program. We actually want to initialize it to false probably every time you load a map. So it's much better that in your load map actually initialize it to false. Don't count on the constructor. Does that make sense? Because the constructor doesn't run off enough for global variable. Any questions on this? It all looks good. Okay, so now I need to change my redraw function. So in my redraw function, and I guess I did, there's basically, I should have written this down, but there's basically a vector of, this actually should be interdata. The vector of interdata called intersections. Okay, so there's a global variable. I showed you the structure, but I forgot to write down the global variable. So there is a global variable, has one of these structures for every single intersection. Okay, so my load maps that are not highlighted, my act on mouse click set one of them to highlighted, whichever one you clicked on. And now my redraw function, let's say I called it draw main canvas. It basically always goes through, it's going through all my intersections and drawing them. So this is the same code, this loop and this code down here is the same as always. I've added in this new code, and all this new code does is it says, if this particular intersection is highlighted, then I want to draw it in red, otherwise draw it in black. Okay, so I just change the color. All seem clear? Okay. So let me quickly demo that. Oops. Let's go down to the bottom of this program. Okay, so all the code I showed you is basically in what I'm running now. Okay, so I'm going to zoom in a bit so the intersections look a bit bigger. Okay, and let's see where my mouse is, hopefully. I'm going to click on this intersection. And nothing happened. All right, so that seems kind of weird. But notice this, if I actually just move over a little, now it highlights. Let's try it again. I'm going to try this one. So I click on it. Again, nothing happens. But if I zoom out, it shows up and it stays showing up. So I click on this one and then this one and then this one, nothing happens. But then if I just move over a little bit, they all show up again. What's going on? Why is this happening? Say it really loud. Right, so I'm getting exactly what I wrote. The mouse callback is called when you click, and it's recording what should be highlighted, but it's not redrawing. Whenever you trigger a redraw, it does the right thing. But it's pretty counterintuitive because as you're clicking on stuff, you don't see anything happen. If you trigger a redraw, something good will happen. So we need to fix this, right? This is going to be super confusing to the end user. Let me show actually, we'll show you one other thing. Okay, so let me zoom in a little bit here. Okay, so I also wrote some code. Well, in that routine, we wrote some code to print out to the terminal. So when we click on this, you can see it does, our mouse callback was called. And we see that the mouse was clicked at a certain XY. We converted that to a certain lat long, and that was the ID of the closest intersection. So our callback's working fine. Everything looks pretty good, except we're not redrawing right away. So let's go back and look at what we can do about that. So we could write some drawing code in our mouse, our act on mouse callback, but that's going to be kind of a mess. We're duplicating some of the code that we put into our redraw routine. So what's better is there's a convenience function called refresh drawing. So you use the EasyGL application pointer, you call it the refresh drawing call, it forces the redraw right away. So after I figured all the new highlighting, I just say redraw the screen right away. And now there won't be any lag and it'll make sense to the end user. So this is going to be pretty common. In a lot of your mouse callbacks and so on, you're going to have this as the last line. The other thing that I'm going to do here is right now we're printing our information to the terminal, which is okay, you can do that, but it's maybe not the most user-friendly. I'd prefer to have this information in the graphics display. And to print one line is pretty easy. EasyGL gives you an easy function called update message that basically prints a message at the bottom of the window. If you want more elaborate messages, okay, then you have to do more complicated things yourself. But to get just one line of output is really easy. Do you remember this from 244? String streams? You seen this before? Okay, so I'm just making a string stream so I can basically create a nicely formatted string. So I just say intersection selected, I say its name, and then a string stream, you can get the actual string out of it using this str member function. If you don't remember that, you just go to c++.com. And this is another EasyGL function. Update message takes a string and it writes it across a little sub window in the bottom of the graphics. Okay, so if I go and run this now, okay, so let me comment out this one. And let's run it. Okay, so let me zoom in a bit. Bigger. All right, so if I click on this guy, it gets highlighted right away. Click on that one. That one's kind of behind something, so partly highlighted. That one highlighted, so it looks good. If I zoom in, they stay highlighted. So it's looking pretty good. And when I click on something, let's see, let me find an area that's interesting. Maybe I can zoom in around U of T. We'll go to the Toronto Islands, okay? She thinks that's Lakeshore. That's pretty weird. So it's printing out the names of, if you look in the bottom down here of the graphics window, you can see that whatever I click on, I'm now getting the name of that intersection printed there. So it's a bit more user-friendly, and it was pretty easy. It's no harder to print to that little status message than it is to print to the terminal. Okay, so let me show you one thing though that's still a bit weird. See if I can find a spot where we've got a little bit lower density of intersections. It's more obvious. Okay, so let's say so if you can see where my mouse is, I'm clearly on a certain intersection, but when I click, it highlights the one beside it. Okay, so that was kind of weird. Move over here, click on this one, highlights the one beside it again. Click on that one, it got it right. Click on that one, it got it right. Click on, let's see. Let's click on this one, got it wrong. What's going on? Seems like I've almost got it right, but sometimes I'm getting the wrong intersection. What do you think? Yeah, that's exactly right. So I'm just going to repeat that in case you couldn't hear it. The intersections are actually at the bottom left of these rectangles. That's the way I drew it. So when we do find closest intersection, we're finding what's closest to the bottom left of a certain intersection. So if I click here, I mean, what gets highlighted actually makes sense, but it's confusing to a user. So how should I fix this? Because it is weird. I'm clicking on the rectangle for one intersection, getting a different one highlighted. How can I fix this? It's not hard to fix. What do you think I should do? Yeah. Right. Yeah, so that makes sense. So you're saying adjust how we draw our rectangle so that it's centered on the intersection. And that's a great idea. So I'm going to actually end this program. And let me go back quickly to here. Yeah, so yeah, we didn't center it. And that is confusing. When people go to click on it, there are lots of ways that I could change my drawing call to make it centered. What I've done here is I've just made another point that is width over 2 and height over 2, and I've subtracted it from the lower left corner to get my new starting point. There's lots of other ways I could write this. There's many different ways to draw rectangles in EasyGL, but this is a pretty convenient one. I shift it over by width over 2 and height over 2, and then I draw there. Okay, so if I do that, go back to my graphics. Let's see. Okay, so I'm going to build that and draw it. Okay, so now when I go in and do it, if I click on that one, I get that one. Click on that one, I get another one. Click on that one, and so on. Okay, so now it's working, right? It's accurate now. Okay, how do I ever, if I run this for a long time, I could get a lot of intersections highlighted. I haven't made any way to get rid of highlighting. Do you think that's a good user interface choice? Yeah, so you've got a few options, but you should make some way to get rid of highlighting. Maybe only highlight the last thing, maybe you shift. You can check that event parameter that's passed to the mouse click to see if shift is held down. You might decide that means unhighlighted. You might have a button in the UI that means don't highlight, like clear all highlighting, but you should have some method where you get rid of the highlighting. So it's because this is not a reasonable choice. It might be reasonable to say you have lots of things highlighted, but there should be some way to get rid of it. So decide on what that is. Okay, and let's see. Adding buttons. So I'll go through this. I guess we're over time. So this is all videotape. So you can always take off and just take a look at what happened in the first tutorial. And I think I have to get out of here anyway. So I suggest you just go online and see how do you add a button and how to use Glade. We're getting into sort of gradually more advanced topics. Using Glade is optional. You do not have to use any GTK functions if you don't want to. They're considered extra features if you do it. The one thing you should do with Glade is what you saw when you came in. Change the name of the program at least, because the name that we give you is example program, which looks kind of silly, and it's pretty easy to change. Okay, thanks everybody. Sure. There's no very quick